continuing to solve. We're solving some more. The only difference is that these are a little bit trickier than some of the ones we've seen. So we keep kind of like stepping it up a notch and a notch and a notch. Today we're going to do a certain type of problem that's going to involve some factoring. So all the stuff we do today is going to involve factoring. And then tomorrow I'm going to save ooh, yes, factoring. And so tomorrow I have two other problems that are a different type. So that way they can kind of stay in their own realm, and so all the problems should kind of match up and we can do one type at a time. Okay, let's look at part A. We're solving. It says, it doesn't tell me what to solve for, so I'm going to say all solutions. So whenever it doesn't give you something like, hey, find the solutions from 0 to 2 pi, just always assume it's all solutions. So I'm going to take a look at this and I'm going to find all solutions. First of all, do you notice that it's problematic that we have more than one trig function? Yeah, I don't love that for us. So let's look and see if there's anything back in section 7.1, all the way back. Do you see the cosine squared? Or cosecant squared, sorry. Okay, look and see if you can find me something that can help me with that. So what is the cosecant squared equal to? This is equal to what? Okay, 1 plus cotangent squared theta. So we're going to start with that. So we want to at least be talking in the same realm, because having two different trig functions is very problematic. So the first thing you want to do is at least get in terms so that everybody is in the same boat. So we're all cotangent, or we're all cosecant, or we're all something. And again, this is where you might go back to 7.1 and use some of those. So on the left, I have 1 plus cotangent squared theta equals, on the right, I have cotangent theta plus 3. Okay. Remember we talked about like squinting a little bit and pretending like the cotangent squareds and stuff were just like u squareds or x squareds. Do you see how this is something that we might be able to eventually factor if you squint and use your imagination? If you are solving anything quadratic, you need everybody on the same side. Yes? So you can factor and solve. Because factoring and solving is going to be the name of the game today. So I'm going to next move everything over so it's set equal to 0. So we want to get everything on the same side. Now, personally, I like it when my thing that is squared is positive. It throws me off when it's not. So I'm going to move the cotangent over and the 3. And I'm going to do it in one step because I want to be efficient. So now there's nothing left. Are we okay with that? On the left, I have cotangent squared theta minus cotangent theta. I line these two up for a reason because they're like terms, right? What do I get when I do 1 minus 3? -2. And now my equals 0 is floating and my perfectionist self can't handle that, so I'm going to fix it. All right, so now we're going to use U substitution, something you're going to see a lot down the road in calc if that is part of your math journey. So the way that we use U substitution is we have to have a let statement. Let U equal cotangent theta. So I'm going to put in a U instead. Could you use X? Yes. Why do they use U? I don't know. There's no good reason. So you could use X if you'd rather use X. All right. So if I go to put in U, well, there's a cotangent, so it's U. What would I put in place of cotangent squared then? U squared. So I have U squared minus U minus 2 equals 0. All right. Can we try to factor that? Yeah. 2 sets of parentheses because it's a trinomial. I know I need U times U to get back U squared. What are my magic numbers that multiply to -2 but add or subtract to -1? -2, +1. Step back and make sure you agree. -2 times 1 is -2. -2 plus 1 is -1, yeah? Okay. All right, so now we're going to put the cotangents back in. So now that we've dealt with kind of the tricky part, we're going to put the cotangents back in. Also, we're going to apply the zero product property. You're going to do two things at the same time. If you have two things multiplied together that equal 0, either this one was 0 or this one was 0, right? Because 0 times this would be 0, or 0 times that would be 0. So one of them has to be 0. Okay, so I'm going to do two things. I'm going to replace the u with cotangent. I'm going to rewrite it so that it's equal to 0. So I'm replacing the u's. I'm subbing back in the cotangent of theta, and I'm also breaking it apart using the zero product property. Something we saw a long, long time ago. All right, on the left, what should I do to solve it for theta? What can I do first? Do what? We're trying to get theta alone. Add 2. Let's add the 2 first. Cotangent theta equals 2. I'll come back and deal with the other one later. I'm even going to just I'm going to do one of these numbers so I don't even think about it right now. I'm going to deal with just this one first. All right, how can I put this in terms of something I know more things about? Do I know a lot about cotangent? Who's his buddy? Tangent. So let's go ahead and rewrite it as tangent of theta equals, what is it going to be equal to? 1/2. So we're going to take the reciprocal. All right. Now, how can I get rid of the tangent? So it just says theta equals. Do what? Inverse tangent of both sides. All right. Now, think about if it's a calculator moment or not. Do I know a value where sine divided by cosine is 1/2 on the unit circle? I don't. That's not a Buddy the Elf, I know him moment. So on my calculator, this is a calculator moment. I'm going to hit second. Oh, wait, let me check my mode. Radians. Okay. Make sure you're still in radian mode. If you're not, this isn't going to go well. So check your mode. We need to be in radians together. I'm going to hit second tangent to take the inverse tangent of 1/2, or I'm going to type 0.5. And I get theta equals 0.46. All right, since we're going for all solutions, what should I add on to that? Ooh, careful. Plus pi k because it's tangent, plus pi k where k does what? Exists in the set of integers. Okay, so this is one of my solutions. And I totally anticipate running out of space because yes, there's another example and I've already written halfway through it. Sorry. Okay, let's uncover this. Oh no, gotta deal with this one still. Okay, same idea though. What would you do first? Minus the 1. Then what? Yeah, change it. So the good news is the process is very consistent. Ooh, what's the reciprocal of -1? -1. Super exciting. And then what should I do? Inverse tangent. Okay, now, before we go to the calculator, I know the last one was calculator, but maybe this one isn't. Are there spots on my unit circle where the tangent is -1? Yeah, because we're dividing sine divided by cosine, and there are a lot of times where sine and cosine are the same. So it won't be in quadrant 1 because I need it to be negative. Where in quadrant 2, what theta is going to give me the same sine and cosine, but one's positive, one's negative? 3 pi over 4. Plus, what should I add? Pi k, where k exists in the set of integers. Look at how many different things we just put together in one problem. We did substitution, we did factoring, we solved an equation, and we dealt with trig functions in the unit circle. Like, that's a lot of things all in one. That's a lot.
Wait, why do we do 3 pi over 7? Yeah, why did you not include 7 pi?
So 3 pi over 4 because you want it to be negative 1. So if you think about your unit circle, if I was here at pi over 4, they would both be root 2 over 2, so it'd be positive 1. But here, one of them would be negative. So that's why I need this one.
Isn't it negative in quadrant 4 too?
Yeah. Yep, that's why we're adding pi k. What's the distance from here to here? I love that you guys are thinking about that though, and making sure we're accounting for all the solutions. All right, next one, ready? I'm just gonna get a new sheet of paper, you guys. This is just not gonna happen. I can already tell. Okay. Next problem. This is part B. 3 sine of 2 theta minus 2 sine theta equals 0. So today the name of the game is going back to section 7.1 and finding stuff we can use, or in this case maybe 7.3. Do you remember the double angle formulas? In 7.3 we were told what sine of 2 theta is. So when I look at this problem, I zero in on this as the most problematic piece of it, right? Because have we had a number in front of the theta when we've been solving that? No. So I zero in on that part because I'm like, oh no, this part, this concerns me. Okay? So let's go to section 7.3. For just a moment. Do you remember what the sine of 2 theta is equal to?
It's 2 sine 6.
So it's sine theta cosine theta times 2. Yeah? And then I still have minus 2 sine theta equals 0. Let's deal with this, because we know order of operations says we have to multiply first, yes? So let's condense that down. On this side, I have 6 sine theta cosine theta minus 2 sine theta equals 0. Now, a minute ago we talked about having the same trig function, right? Like we didn't want multiple trig functions. That is true about 90% of the time, that we want to be all the same trig function, unless we can factor something out so that way what we have left is all the same trig function. So can we pull something out front that they both have in common?
2 sine.
I heard, yes, 2 sine, and you need the theta. And then let's see what will be left over. So again, factoring is also the name of the game for these problems today. So the tricks that you're using are 7.1 and 7.3 theorems, formulas, identities, and then you're also thinking factoring. All right, 2 times what gets me back to 3? Or 2 times what gets me back to 6? 3, I wonder. Okay. And do you see how I still need a cosine as well? Yes. So let's do that. Minus, what's going to go here? 1. So again, we like to be all in the same trig function. So all sine, all cosine, all tangent, all cotangent, whatever it is, unless you can factor one out from the other. All right, so we have zero product property again. One of those things has to be 0. So either 2 sine theta equals 0, or 3 cosine theta minus 1 equals 0. Okay, let's start with the one on the left. How can I solve for sine theta? Divide by 2. What's 0 divided by 2? More 0. How can I undo the sign? Inverse sine. Okay, think about your unit circle. We need our sign to be 0. Where does that happen? Zero and pi. So make sure you think about the most concise way that you can write it. So if we've got solutions, sometimes it helps to make a list. So 0 is a solution, pi is a solution. Would 2 pi be another solution? What about 3 pi? Okay, so we need to think about a way to write that concisely, that all the pi's are solutions. How might you write that? Pi k, where k, what? What does k do? Exists in the set of integers. Because then you'll get 0 and 1 and 2 and 3, and then you'll also get the negative values as well. Okay, let's go to the other side. What should I do first? Add the 1. 3 cosine theta equals 1. Then what? Divide cosine theta equals 1/3. Okay, now what should I do? Inverse cosine. Okay, think about Buddy the Elf. Is this a thing that's on my unit circle? No, I don't know him. So I could use what if I don't know him? Calculator. So if you don't have your Buddy the Elf moment, then you use your calculator. Second cosine, 1 divided by 3. Theta equals 1.23. Now, before we throw that down as our answer, I want to remind you of something. Okay. If 1.23 is a solution, it lives here-ish, right? What do we know about those sister solutions? There should be another one. It's only going to give me one solution. We need to be smarter and know that there are 2 within one revolution. Where's the other one going to be? In the 4th quadrant. Because it's cosine, they should be the same distance this way. So I need another solution, but down here. So you need to find your sister solutions. When we did the tangent problem, we didn't have to worry about that, right? Because you add pi k, and so it already takes care of the issue. With sine and cosine, you do have to find the sister solutions. So this is, one revolution is 6.28. If I subtract off 1.23, this is 5.05 right here. So I need, yeah?
Why wouldn't you add pi k to it in the...
Because pi would get me to here. It wouldn't take me to the right spot. So there's no way to concisely write it, or I would do that. That would be lovely if I could, but it doesn't work that way, unfortunately.
What did you add to get
So do you see how I knew this was 1.23 this way? This is 1.23 this way. So I did, do you see how it's short of 2 pi?
Yeah.
By 1.23? So I did 6.28. 6.28 is 2 pi minus the 1.23.
Okay.
Good? Okay, so we have 2 more statements to write. What should I write? What's one of them? 1.23 plus 2 pi k, where k exists in the set of integers. So let me box these in so I know where all my final solutions are, because I'm just writing everywhere at this point. What's my other solution? Yeah. So let's take it way back for a second. If I took this value, or I took this value plus 2 pi, and I plugged it into the original equation, it should make it equal to 0. So could I check my work? Yeah, it wouldn't be the easiest, but I could. Okay, so keep in mind that that's still an option too, to go back and check your work. Are you ready for homework? I didn't give you a lot because I'd rather have you do a few well than a lot with not as high quality of work. You like the idea? Good news. Homework, page 528. Numbers 3 to 8. You might even find you have enough time to do them all.